Welcome to Boring Mathematics for Sleep. If you've ever looked at a number, say a 7, and thought, yes, this is the content I need to end my day, then you, friend, are exactly where you're meant to be. Tonight's journey is one of quiet mystery. No monsters, no action, no big drama, just numbers, and not even the exciting kind, if such a thing exists. Not statistics or equations or tricky brain puzzles. No, tonight we're going all the way back before numbers had names, before we knew what 7 even was, before math had rules or textbooks or math teachers who ruined everything. We're going to explore how humans, like you and me, went from confused little cave people grunting at each other to eventually saying things like, I believe that's an improper fraction. A bold evolutionary leap, if you ask me. So get comfortable. Pull the blanket up to your chin. Make sure your socks are mismatched, because that's mathematically lucky. Probably. And let your eyes start to close slowly. Let's go back to the beginning. Back before calculators, chalkboards, or that one weird kid in school who could do cube roots in his head. Let's go back to the moment when someone, somewhere, looked at 2 sheep and thought, wait, didn't I have 3? And just like that, math was born. You see, numbers didn't fall from the sky. They weren't written into the DNA of the universe, like some cosmic cheat code. We invented them. Out of confusion, out of need, out of counting livestock that kept wandering off. And before that invention, before the symbols and the counting and the occasional calculator-based cheating on math quizzes, there was nothing. No 1, no 2, no 6, not even a 0. That guy shows up fashionably late. So how did we get from blank stares and hungry bellies to entire civilizations built on digits? That's what we're here to gently, slowly, ever so sleepily explore. Tonight, we'll walk beside ancient herders, scribes with worn-out styluses, Babylonian bean counters, and a few extremely stressed monks. We'll dig into bones with notches, clay tablets, dusty scrolls, and the world's least helpful Roman math system. Spoiler alert, they didn't believe in 0. We'll gently uncover the story of pi, place value, Fibonacci and his rabbits, and how 0 changed everything by meaning absolutely nothing, and we'll do it all in the softest, most meandering way possible, so that by the time we get to the invention of the number 4, you might already be softly snoring, which would be flattering really. So take a breath, let your thoughts float away, the emails, the laundry, whatever that thing was you forgot to do today. You're here now, listening to the history of numbers, told very slowly, by a voice that understands your need to forget everything and just rest. Welcome. Let's begin. South. Let's set the scene. It's 40,000 years ago. There's no Wi-Fi, no pizza, no TikTok, just dirt. And maybe a stick, if you're lucky. You are an early human, possibly wearing fur, definitely confused. And you've just left your camp to collect berries. Simple enough. You head out with your usual tools, sharp rock, flat rock, and what you might generously call hope. You pick berries. You eat a few. You stash a bunch in a basket made of bark or possibly an old mammoth ear. Then you head back. You feel good. You feel accomplished. And then your friend, let's call her Karg, asks, "Did you bring more berries than yesterday?" You stare at her. You blink, and you realize something horrible. You have absolutely no idea. This, right here, is the birth of mathematical frustration, and it's kind of beautiful, because before we ever had words like 34 or a dozen, before we invented the actual idea of number, we still needed to remember things. How many animals are in the herd? How many people went out to hunt? And how many came back? Side note, if those numbers don't match, that's kind of a problem. So we invented something before numbers. We invented memory aids, clues, little artifacts to remind us how many things there were, even if we didn't yet have the language to say it out loud. Let's meet the Ashango bone, found near the headwaters of the Nile and estimated to be over 20,000 years old. This little artifact, a fibula of a baboon no less, is carved with dozens of tiny notches, neat rows, some grouped, some spaced. Historians aren't totally sure what they mean. Some say it's a lunar calendar, some think it's an early counting tool, and some just think someone was really bored with a sharp rock. But no matter the exact purpose, one thing is clear. This was a human being trying to record quantity. Not 5 or 12. They didn't have those words yet, but they could scratch a mark for every rabbit or berry or fish, and suddenly there was something to remember, a physical reminder of what had been. Not unlike a grocery list, except way more dramatic. Now, these weren't the only marks in the prehistoric world. Similar bones have been found in Central Europe and in the Lobombo Mountains between South Africa and Swaziland, where notched sticks date back even earlier. They weren't just scratching things randomly. Some of the marks show clear groupings, 5s, 10s, even 2s, which suggests, and this is fun, that humans may have been thinking in base systems before they even had numbers to base anything on. Try to imagine that for a second. You're living in a cave, your fire keeps going out, there's a wolf giving you suspicious looks, but still, you're grouping things into sets of 5, because apparently we can't help but organise the chaos, even if we're mostly just trying not to get eaten. Let's talk fingers, because if you think early humans invented the base 10 system because it's logical, let me introduce you to your own hands. 10 fingers, 10 little tools, and the perfect portable abacus. The human hand may very well be the first calculator, useful for counting, holding berries, and pointing dramatically at mammoths. It's not a coincidence that so many cultures developed number systems around 10 or 20, fingers plus toes, or even 5, which, let's be honest, is where most of us stop paying attention anyway. Imagine a group of early foragers sitting around a fire, waving their hands like 2 wolves, 2, and the others responding with, "Ah, fingers, yes, 2 wolves." Humanity. Solving problems, 1 finger at a time. Now, here's a weird thought. Before language had numbers, how did people talk about quantities? Turns out, in many early languages, they didn't. Some tribes in remote areas of the Amazon were still up until recently using words that essentially meant 1, 2, and many. That's it. 3 coconuts? That's many. 5 spears? Still many. 1,000,000 angry bees? Yep, just many. And honestly, that's kind of peaceful. I can't help but think they were onto something. Because while the modern world says track everything, measure everything, monetize everything, those early humans were just out here living their lives and maybe, just maybe, sleeping a lot better than we do. As humans got more clever, or maybe just more forgetful, we started inventing clever ways to track things. One common trick: pebbles, simple, portable. You put 1 in a pouch for every goat you own. You lose a goat. You take out a pebble. Boom. Ledger balanced. The Latin word for pebble, calculus. Yep, that's where we get calculate and calculator from. So the next time someone says they're doing calculus, just picture them squatting in a field, counting rocks. It helps. Other ancient societies used knotted cords, the quipu of the Inca being the most famous. Different knots, positions, and lengths recorded everything from taxes to census data. You could argue that a well-tied quipu was basically a spreadsheet made of string. Excel, but make it woven. So before there were numbers, there was still math. Not the kind with symbols and equals signs, but the kind that lives in pattern, memory, repetition, and rhythm. The pulse of footsteps, the spacing of stars, the number of fish pulled from a net, counted with stones dropped into a pouch, one by one by one. This wasn't abstraction, it was survival, and maybe, just maybe, a little bit of magic. Because in the quiet of the Paleolithic night, around a flickering fire, a child might hold up their hand and say nothing at all, but show 5. And that gesture meant, I was here, I remembered, and I understood. Next, we'll leave the caves behind and walk slowly into the birth of civilization, where people weren't just counting sheep, they were taxing them. But for now, rest. You've survived the first age of math, and you didn't even have to solve for X. So you've survived the caves, you've counted some berries, you've accidentally invented a base 10 system with your fingers. Well done. But now, things are about to get organized, and, depending on how you feel about taxes, maybe a little annoying. It's around 5000 BCE, and humans are doing something very dangerous. They're settling down. No more wandering around the forest in search of mushrooms and spiritual clarity. Now we're farming, building homes, stacking stones into impressive piles, and, most terrifying of all, sharing stuff. Grain, mostly, but also livestock, tools, land, and the occasional overly friendly goat. And here's the problem with stuff. Someone always wants to count it. Welcome to Mesopotamia. Literally the land between the rivers, also known as where paperwork was invented. Here, somewhere between the Tigris and Euphrates, humans decided they wanted cities, and fields, and trade. And in order to do any of that, they needed a way to keep track of who owed whom what. Because, let's be honest, if you gave your neighbour 12 sacks of barley and they returned 3, you'd want a way to remind them politely, and by politely I mean in writing on clay forever. So they made tokens, little clay shapes, each one representing a specific item. A cone might mean a sack of grain, a sphere could mean a sheep, a pyramid, something dramatic, possibly unpaid beer debt, and at first they just traded the tokens around. Simple, no lies, no apps. But eventually, someone got the brilliant idea. Let's seal them in a clay envelope. You could literally put the tokens into a hollow clay ball, seal it shut, and then scratch symbols on the outside to show what was inside. Congratulations, that's a receipt. You've just invented accounting, and also bureaucracy. Eventually, people realized, hey, we don't need the tokens anymore. Let's just scratch the marks straight into the clay. And just like that, we went from 3D to 2D, from lumps to lines, from pebbles to writing. The earliest writing in human history isn't epic poetry. It's not religious texts. It's not love letters. It's ledgers, records of sheep, grain rations, land boundaries, basically spreadsheets in wedge-shaped cuneiform on clay for eternity. Soon, counting took on bigger roles, not just how many goats did I lend Greg, but also how many soldiers do we have, how much food to feed a city, how many days until the river floods again. Counting became planning. Planning became power, and the ones doing the counting, they weren't just farmers anymore. They were priests, scribes, kings, and, of course, tax collectors. Nothing says civilization quite like a man in a robe knocking on your door with a stylus and a clipboard made of mud. The word tax might raise your blood pressure, so let's say it very gently. Taxes, back then, weren't dollar bills. They were more like, hello, you grew 10 bushels of wheat. Please give us 3. Because temples. And you couldn't really argue, because the priests were also in charge of writing things down. So they'd just make a note that you were now in debt to the gods, which is a hard reputation to shake. Counting wasn't just about sheep and barley, it was about time. If you plant at the wrong time, your crops fail. If you forget the rainy season, you drown. So ancient societies began to count days, moons, stars. Calendars were born, some based on the sun, some on the moon, and all deeply confusing if you forgot to carry the one. The Babylonians, for instance, loved the number 60. Why? Possibly because it's divisible by many things, or maybe because they were just extra. That's why we have 60 seconds in a minute and 360 degrees in a circle. You can thank ancient Mesopotamian math. And if you're still wondering why your clock resets every 12 hours, well, now you know, because Sumerians thought it was neat and the rest of us just never questioned it. With counting came commerce, and with commerce came the need to share numbers across regions, tribes, and eventually empires. This is when we started getting symbols for numbers, not just scratches and tallies, but consistent marks that everyone in a region could understand. It's around this time that we start seeing full-on number systems emerge. Not just how many, but how to write it down. The Egyptians used pictures, the Chinese used rod numerals, the Maya carved symbols into stone. Every culture had their own math dialect. Some were efficient, some were chaotic. Some were so confusing that even the scribes probably needed a nap. So let's pause for just a moment. Close your eyes. Picture a Mesopotamian scribe hunched over a tablet, recording grain deliveries while the sun sets behind mud brick ziggurats. He's tired. His stylus is dull. He's writing the same number over and over. But in doing so, he's creating history and quietly, gently, shaping how humans think about the world forever. Because counting, once just a way to remember how many berries you picked, had become culture, a shared language of order, a soft structure beneath everything, from harvests to taxes to time itself. And now, dear listener, you know the secret truth. All civilization is just advanced counting, and that is both terrifying and oddly comforting. Next, we'll explore the rise of real number systems, the weird symbols, the ancient math hacks, and how the Egyptians used math to build immortality out of stone. But for now, rest. The scribes are asleep, the barley's been counted, and your dreams are entirely tax-exempt. Welcome back. You've counted the barley, you've survived the Mesopotamian tax audit, and you've watched numbers crawl from memory into clay. Now, it's time to meet the first real number systems, the written kind. The good, the bad, and the how on earth did anyone use this? Let's go back to Egypt. The Egyptians, they gave us pyramids, they gave us mummies, and they gave us some of the least practical numerals ever devised. But boy, were they beautiful. Egyptian numbers were written using hieroglyphs, little pictures. A single stroke for 1, a heel bone symbol for 10A, coil of rope for 100A, lotus flower for 1000, a finger of God for 10,000, a tadpole for 1,000,000. Yes, a literal tadpole. It was like writing math problems inside a Renaissance painting. And if you wanted to write, say, 2,434, you'd draw 2 lotus flowers, 1,000 each, 4 coils of rope, 100 each, 3 heel bones, 10s, and 4 single strokes, 1s, which meant your homework looked like ancient fan art. Adorable, impractical, timeless. Now, did they have a 0? Nope, not even a whisper of it. Because to ancient Egyptians, what wasn't there didn't need recording, which is noble until you're trying to do long division and the whole number line collapses under its own philosophical weight. Still, you've got to admire a civilization that could bury a pharaoh with 80 tons of treasure but would not write the number 0. And here's something truly fun. Those pyramids. Yes, the ones still standing. They were built using astonishingly precise mathematical ratios. Measurements so accurate, some people have, incorrectly, suggested aliens were involved. But no, it was just really good math. Math with fractions, no calculators, and questionable sandals. Egyptians even had a fraction system that mostly used 1 over something, like 1/2, 1 quarter, 1/8, and then stack those up to make bigger numbers. So if you wanted to write 3/4, you wouldn't write 3/4. You'd write 1/2 plus 1/4. It's like they invented the world's first jigsaw puzzle and then used it to solve for X. Now we cross the desert back to Mesopotamia, where the Babylonians were doing something very weird. They invented a number system based on 60. Yes, 60. As in the number of seconds in a minute. The number of awkward small talk seconds in an elevator. Why 60? Because it's what mathematicians call superdivisible. It can be evenly divided by 2, 3, 4, 5, and 6, which makes fractions behave nicely. It also makes your number system really hard to learn unless you're an insomniac goat herder with a lot of time on your hands. Babylonians used wedge-shaped styluses on soft clay, creating symbols that looked like bird tracks running a marathon. Their number system had no zero at first, which again becomes a running theme in this era. So whether a symbol meant 1 or 60 often depended on context. So if you're wondering why some Babylonian accountants probably drank heavily, this might explain it. But the Babylonians gave us gifts, 60 minutes in an hour, 360 degrees in a circle, the earliest algebraic equations, and the concept of square roots, written 4,000 years ago on Clay 1 famous tablet. Plimpton 322 lists Pythagorean triples long before Pythagoras was even born. It's like they invented trigonometry and forgot to brag about it.
Now, let's gently stroll east to ancient China. Here, counting took a more elegant form. Wooden rods placed on flat surfaces, like a counting board. The position of each rod mattered. A vertical rod might mean 1, but a horizontal rod in the next place over could mean 10. It was a decimal system, based on powers of 10, an idea so good we still use it today. Rod numerals allowed for fast calculations and were a favourite tool of scholars and merchants alike. But most importantly, they were silent, and as anyone who's ever taken a math test knows, silence is key when pretending to know what you're doing. China also gave us Teike, the earliest known magic squares us, the use of negative numbers, and eventually the abacus, a mathematical fidget toy for the Enlightenment era. Now, we hop continents to the lands of the Maya. Here, numbers weren't just for trade and taxes, they were sacred. The Maya used a vigesimal system, base 20, because fingers and toes deserve recognition. Their symbols were beautiful, debts for ones, bars for fives, a shell symbol for 0. Yes, they had it, long before Europe even considered such heresy. In fact, the Maya were among the first to consistently use 0 as a number, not just as a placeholder, but as a full citizen of the math community. They used their system for everything, measuring time, building pyramids, writing eerily accurate calendars that still confuse people today. Imagine doing all that, with bars, dots, and divine inspiration. It's humbling, and slightly intimidating. So what do we have so far? Ekete, Egypt turned numbers into art. Babylonians invented stressful fractions. Chinese scholars finessed rod math. The Maya gave us 0 with flair, all of them trying, in their own sleepy, brilliant ways, to describe the world through symbols, and none of them had calculators, or coffee, or helpful math YouTubers. They did it with sticks, bones, bars, and clay, and they created systems that still echo in your daily life. Every time you check the time, draw a triangle, or round something up at the grocery store, you're using tools that were shaped by these ancient minds. So maybe tonight, as you drift off, you'll dream not of numbers on a screen, but of a quiet scribe, carving birdfoot numbers into clay, and humming softly to himself. Next, we'll talk about the most controversial number of all, 0, the empty idea that changed everything. But for now, just breathe. You've earned your rest, and in base 60, that's worth quite a lot. We've wandered through pyramids. We've met frog-shaped numbers and clay-based spreadsheets. We've counted with fingers, pebbles, and sticks. But now, it's time to talk about nothing. Literally, let's start with a simple question. How do you count nothing? Not just a lack of things, but a way to write that absence down. A symbol that means there is a space here, and it matters. You see, ancient number systems were clever. They tracked sheep, harvested grain, calculated taxes, but they all had a problem. Without a placeholder, numbers could get confusing. If I write 21, is that 21 or 201? Who knows? Not even the person who wrote it. What we needed was a hero, a symbol, a tiny circle of logic, an idea so radical, so deceptively simple, that it terrified entire civilizations. That idea was zero. Beck. A story of zero doesn't begin in Greece, or Rome, or even Mesopotamia. It begins in India, around the 5th century CE. A mathematician named Brahmagupta, which is an excellent name to whisper as you fall asleep, was one of the first to write rules for zero. Not just use it, but define it. He treated zero as a real number. He even described how zero behaves with other numbers. A number minus itself is zero. Zero times anything is zero. But zero divided by zero, that, dear listener, is still a problem, and always will be, a poetic kind of nothing. Like the feeling you get after finishing a bag of chips and realizing you ate the whole thing. This little symbol, just a dot or a circle, quietly rewrote the rules of arithmetic. And it did something more important than that. It gave meaning to place. Imagine writing 408 without a zero. What would that even look like? 4, 8, 4, 8, 8, 4. Who's to say? With zero, suddenly numbers gained depth. A zero in the middle said, there's a place here but it's empty. Please respect the emptiness. That's called a positional system. Each digit has a value based on where it sits. The 4 in 408 is worth 400, the 8 is worth 8, and the 0, it's just holding space, like a polite guest at a very complicated dinner party. Before 0, people had to create new symbols for every number, but with 0 and place value, you only need 10 symbols, 0 through 9, and you can build every number that ever existed. It's like discovering you only need 10 Lego bricks to build every castle, spaceship and dragon imaginable, as long as you stack them correctly. That's how powerful place value is, and that's why your calculator and your bank account owe India a big thank you. Now Brahmagupta didn't have a podcast or a TikTok to explain 10 weird zero facts you won't believe. So how did zero spread through the Islamic Golden Age, a period where Arab mathematicians, philosophers and scholars translated Indian texts and expanded upon them? They called zero sifar, which gives us the word cipher, and eventually the word zero itself. These scholars loved math. They refined algebra, mapped the stars, built astrolabes, and they knew that this strange, empty circle wasn't just useful, it was transformational. By the time it reached Europe, though, zero caused a bit of panic. In medieval Europe, the prevailing number system was still Roman numerals, which, if you've ever tried to do long division in Roman numerals, I'm sorry, that sounds like a terrible day. They didn't have zero or place value, or even good vibes. And when merchants and scholars began bringing Indo-Arabic numerals into Italy, the reaction was not great. Some people called zero the devil's symbol, because of course a number that stands for nothing must be up to something. Cities like Florence even tried to ban it. They feared it could be used to falsify ledgers, because, nothing is suspicious. Imagine banning zero. That's like banning silence, or naps. Tragic. Enter a man with excellent branding, Leonardo of Pisa, better known as Fibonacci. In the early 13th century, he wrote a book called Liber Abaci, which sounds like a magical spell, but is really just a long explanation of numbers. In it, he explained how Indo-Arabic numerals including zero, were vastly superior for commerce, calculation and everyday use. He also introduced the Fibonacci sequence, but we'll save that for another sleepy night. His book quietly changed how Europe thought about numbers, and while zero didn't go viral overnight, it began to settle in, slowly, softly, like dust on a ledger. As math progressed, people began to realize something strange. Zero, the smallest, emptiest concept, was also the gateway to infinity. After all, once you understand that numbers can go down to nothing, you also understand they can go up forever. Calculus, physics, astronomy, all of them rely on zero to describe change, speed, and the vast stillness of space. Isaac Newton used zero to describe how objects move. Einstein used it to describe gravity. Your toaster probably uses it without even knowing. Zero is both absence and potential. It's a placeholder, a concept, a circle of possibility. And yes, it also shows up in your bank account after you buy too many snacks on a road trip. So tonight, let us take a moment to appreciate this tiny, weightless, elegant idea, a number that means nothing, but gave us everything. Without it, we couldn't build skyscrapers, we couldn't explore space, we couldn't text someone 0110, no notes after a bad date. Zero changed the world by doing absolutely nothing. And now, as your eyes grow heavy, remember, sometimes it's the quietest things that shape the loudest parts of life. And sometimes nothing is exactly what you need. Let's say you've just invented zero. It's beautiful, elegant, useful, and round, like a bagel of mathematical perfection. You'd think the world would celebrate, embrace it, throw a party with string lights and triangular cheese. But no, because here comes Rome. The Roman Empire gave us many things: aqueducts, roads, togas, Latin root words, and at least 17 movies about gladiators. But what they did not give us was a helpful number system. Let's look at the basics of Roman numerals. Ga, i.e. 1, that's I. Want to write 3? 3. You're doing great. Now try 4. That's IV, which is 1 before 5. Why? Because the Romans in their wisdom thought subtraction was spicy. 9, i.e. 1 before 10. 49, x 9, 10 before 50, and 1 before 1987, that's MCML x 11 7, which looks like someone lost a Scrabble game and took it personally. Now you might ask, why use such a confusing system? Great question. Here's the answer. Because tradition. Roman numerals weren't built for convenience. They were built for recording, displaying, and, let's be honest, looking fancy. You'll still see them today. There, on monuments, on clocks, on Super Bowl posters that confuse everyone, and in film, where you learn the year the movie was made, if you can decode it. But back then, Roman numerals were state math, used by elites, scribes and military officials. No abacus required, just a trained memory and a lot of faith. Imagine trying to multiply LX11. Now imagine doing that by candlelight, while wearing a tunic. That's real suffering. So here comes the twist. Even after zero and place value were introduced in India, translated by Arab scholars, and brought into Italy through merchant trade, Europe still said, no thank you. Why? Because the Roman Church, the nobility and the academic class, were very fond of tradition. Roman numerals were tied to law, to money, to land records. They were familiar, they were official. So when someone suggested a new system with strange curved symbols, and gasp a zero, that felt like heresy, dangerous, foreign. Some cities literally banned Arabic numerals. They feared it would make cheating easier. Spoiler, cheating is still pretty easy. It's like if someone today invented a way better keyboard, but everyone refused to use it because QWERTY feels right. Despite resistance, Arabic numerals began to spread, but not through universities, not through priests, through merchants, shopkeepers, traders, market counters. They realized something quickly. It's hard to divide 8 goats by 3 over v. It's easier to just write 8. Also, goats don't like being fractioned. So shopkeepers started using Arabic numerals quietly, writing them in the margins, on slates, in secret ledgers behind the counter. It was underground math, rebel math, decimal punk. Meanwhile, monasteries were still teaching Roman numerals and pretending zero didn't exist, which is ironic, because that's what I got on most of my Latin tests. In his book Libera Baci, Gel 102, he didn't just explain the Fibonacci sequence, he also promoted Indo-Arabic numerals as better for business, for accounting, for calculation. His writing wasn't flashy, he wasn't trying to go viral, but he quietly laid the foundation for Europe's slow, stubborn shift from Roman numerals to something more usable. It took centuries. People clung to what they knew. Roman numerals lingered in legal documents, royal decrees, and architecture, and even today they haven't fully gone away. You'll still see them in Taisi, clocks that say 3i instead of IV, just to be symmetrical, copyright dates that make your brain itch, and graduation diplomas that make you wonder if MMXX5 is a blood type. Europe used a number system that everyone knew was inefficient just because it had always been that way, which, if you've ever worked in an office, feels deeply familiar. Change is slow, especially when it comes with scary symbols and new ideas, but slowly, gently, over time, zero crept in, place value took hold, and Roman numerals faded quietly into decorative font. Yes, it made long division feel like gladiatorial combat, but it got us here. It was part of the bridge from ancient math to modern math, from empire to enlightenment, from I to infinity. Next, we'll explore how modern numbers spread, from dusty books to dusty classrooms, and into the minds of students everywhere who forgot their homework. But for now, close your eyes. You've earned your MCMXC. By now you've met all the strange cousins of numbers. Clay wedges, frog hieroglyphs, finger math, rebellious zeros. You've tiptoed through caves, scribal chambers, Roman tax offices, and at least one extremely stressed monk. And finally we arrive here, in the moment the world collectively said, okay, fine, this number system actually works. But it didn't happen quickly, or easily, or politely. Like most great ideas, modern numbers spread through quiet rebellion, trade deals and very nerdy books. Let's begin by admiring something so simple, we almost forget how brilliant it is. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. 10 symbols, 10 little squiggles, 10 abstract marks you can draw in the dirt with a stick, and with them you can write any number. Literally any number, from the distance to the sun, to the number of raisins you just accidentally spilled in your bed. You can thank India for inventing the symbols, Arab mathematicians for spreading them, and Italian merchants for realizing that Roman numerals were a terrible way to write receipts. In the Middle Ages, math didn't spread because of textbooks, it spread because of money. Merchants traveling between Italy, North Africa, Persia, and beyond needed a way to calculate prices, measure fabric, and track debts without spending an hour subtracting x from L. Arabic numerals with their place value and sweet zero made things faster, clearer, and less likely to get you yelled at by a customer buying 4 goats and a rug. That's why you start to see strange math pop up, not in royal courts, but in shipping manifests and ledgers with suspiciously round zeros, mistake by mistake, usually by candlelight, with a cranky scribe muttering under his breath. But with Gutenberg's invention around 1440, you could print a book 100 times faster, which meant more math books, more textbooks, more opportunities for people to read the sentence, solve for n, and cry softly into their robes. With printed numerals came more consistent symbols, more sharing of ideas, and tragically, more math homework. Arabic numerals became standard in schools, businesses, banks, and finally, in government, because once the tax office adopts a number system, you know it's serious. But one by one, Europe standardized them, The Islamic world refined them, Asian cultures incorporated them, and eventually even cash registers in 7-Elevens across the world began beeping in base 10. It wasn't just math anymore. It was global literacy, and these 10 symbols, once scratched in sand, became the backbone of science, finance, and accidentally tipping 200% on restaurant bills. Math in your pocket. Calculators, those magical plastic bricks of anxiety, turned even long division into a peaceful beep. And computers, they took the same 10 symbols and translated them into binary, zeros and ones, which is basically just numbers but cold. Even your smartphone, which you're probably listening to this on right now, is quietly doing trillions of calculations using numbers that were once drawn on bone with a rock. Let that settle in for a moment. The exact same numeric system that built the pyramids, baffled the Romans, and spread through Silk Roads is now powering cat videos and weather apps. You're living in the future, and it's built on 0 through 9, on your watch, phone, wristband, toaster, and some people, bless them, even enjoy using spreadsheets. They color code cells, they make pivot tables, they say things like compound interest without flinching. To them, numbers are not a burden, but a language. And for the rest of us, well, we're just trying to remember our email passwords and not mix up the tip calculator with the calculator.
Still, whether you love math or avoid it like a pop quiz, you're participating in something ancient, global, and quietly amazing. You're using symbols that started as cave notches and became the infrastructure of civilization, all without thinking about it. Until now. So tonight, as you let your eyelids grow heavy, remember that these numbers you see every day aren't just tools. They're stories. Stories of merchants whispering sums over silk, of monks reluctantly copying digits between prayers, of children learning to count to 10 on their fingers, just like someone did 10,000 years ago. We don't all speak the same language. We don't all believe the same things, but we all, every one of us, use numbers. It's our quiet common ground. Next time, we'll explore the nature of numbers themselves, philosophy, mystery, beauty, and that odd feeling you get when you look at P and think, why are you like this? But for now, rest. There are no problems to solve, no forms to fill, only the peaceful comfort of 10 strange symbols and the humans who carried them here. Close your eyes, picture a number, any number. Maybe it's a lonely little 4, or a dramatic 7, or something fancier, like a gentle, swirling, mysterious P. Now ask yourself this: where is that number? Not physically, not written on paper, but really, does it exist somewhere out there in the universe, or did we just make it up? Tonight, we ask a question so gentle and unanswerable, you may fall asleep just trying to hold on to it. Are numbers real? These folks believe that numbers are real, not invented, but discovered. To them, numbers exist in some higher realm, a perfect mathematical world that humans tap into, like tuning a radio into the frequency of truth. In this view, 2 existed long before humans walked the earth. It existed when stars first lit the sky, when galaxies collided, even when you lost 2 socks in the dryer, a moment of cosmic connection. Then on the other side, we have the nominalists, or formalists, who say, hey, numbers aren't real, they're just a language we made up to talk about quantities. In this view, math is a brilliant invention, a tool like a measuring cup or a sleep podcast. It helps us organize reality, but it doesn't exist outside of human minds. So, is the number 5 floating in space somewhere, or is it just a label we slapped on a group of apples? Honestly, even the apples are confused. In nature, the spiral of a seashell follows the Fibonacci sequence. The petals of a daisy, often number 34, 5 are 89. Fibonacci again, the angles of leaves, the spacing of branch, the swirl of galaxies, all seem to hum with math. It's as if the universe itself is solving problems, whispering equations, and drawing invisible blueprints behind the scenes. Some call this divine design. Others say it's just efficient biology. But either way, numbers seem to be embedded in reality, like the universe's own quiet user manual. And then,
There are the numbers that don't even try to be normal. Imaginary numbers, like 101, a number that doesn't exist, and yet it's used in quantum physics, engineering, fractals, and even music processing. Imaginary numbers power real technology, which is kind of hilarious, because it means our phones work because of math that technically doesn't exist. Try explaining that to your high school algebra teacher. And then there's pi, the drama queen of numbers. Irrational, transcendental. It never repeats. It never ends. It just goes on, forever. Some mathematicians see pi as the fingerprint of the universe. It shows up in circles, of course, but also in probability, physics, engineering, music, and randomness. It's like a number that just couldn't pick a major. And yet, there it is, whispering quietly in everything round. But maybe numbers aren't in the universe. Maybe they're in us. Even toddlers know that 2 cookies are better than 1. Even birds can count their eggs. Some neuroscientists believe we have a built-in number sense, like a FOSS internal calculator, just humming quietly in the background. We're drawn to symmetry, to balance, to patterns. Because patterns are comforting. They help us predict, feel safe, fall asleep to the same rhythm every night. Maybe numbers aren't real because they exist in the world. Maybe they're real because they exist in us. Infinity is not a number, it's an idea, and one that makes mathematicians dizzy in a delightful way. There's infinity, then bigger infinities, then infinities between those infinities. Some infinities are so large they can't even be described without making your brain gently melt. And yet, we use it every day when we say forever, or never ending, or this meeting could have been an email. Infinity is the edge of math, the moment numbers stop being tools and start becoming poetry. So, are they real? The truth? We don't know, but maybe it doesn't matter, because real or not, numbers work. They keep airplanes in the air. They help us write music. They guide robots on Mars. They let us share memes and build bridges and fall asleep listening to videos like this one. That's more than enough. So tonight, as you drift towards sleep, let a quiet little number tuck you in. Maybe it's 3, maybe it's 12, maybe it's pi, humming softly in the background of your dreams. You don't need to solve anything, or understand it all, or choose a side in the great Platonic debate. You just need to know you are part of the story numbers tell. And the next time you look at a clock, or a star chart, or a gentle swirl in your coffee foam, you might just whisper, "Ah, there you are, old friend." Next, in our final chapter, we'll say goodbye, gently, with one last story. But for now, float through a sea of numbers, let them carry you, and rest. So here we are, the end of our story, the last little digit, the closing bracket on a journey through 40,000 years of math, told at the speed of dreams. You may not remember all of it. In fact, if this video worked the way we hoped, you might not remember any of it. And that's okay, because even if your brain drifted somewhere between Babylon and Fibonacci, you've been counting with us all along. You counted the notches on ancient bones, the pebbles in a pouch, the stars tracked by farmers in ancient fields. You sat beside scribes etching numbers into clay, and monks copying equations in quiet, candlelit corners of stone monasteries. You followed numbers as they crossed oceans, snuck into ledgers, and eventually glowed back at you from the device in your hand tonight. And even now, lying here soft and still, your body is still counting. Each breath, each heartbeat, each slow blink of your tired eyes. Your body is doing quiet math, automatic, beautiful, just for you. Maybe numbers aren't just tools or labels or facts. Maybe they're reminders. Reminders that even in the vastness of time, in all the chaos and noise, there is still order, balance, symmetry, and the gentle hum of something you can understand. Something countable, predictable, comforting. Tonight, the world may seem big, and sleep may feel far away. But here, in this little pocket of quiet, You are safe, surrounded by stories and by the numbers that made those stories possible. The ones that told us how far we've come, how much we've built, how many stars are left to wonder about. So as the digits fade into mist and your thoughts float wherever they need to go, just remember this. We started with nothing, a blank cave wall, an empty hand, a single lost goat, and somehow we ended up with everything. A universe, a system, a story, written in numbers. Thank you for trusting us with your time, your thoughts, your rest, and above all, thank you for listening to a very, very boring story about numbers.